ഈ സായാഹ്നത്തിൽ പ്രത്യേകിച്ച് മുഖവുരകളൊന്നും കൂടാതെ ശ്രീ രാഘവപുരം സഭായോഗത്തിന്റെ എല്ലാ ധർമ്മകാംക്ഷികളെയും സജ്ജനങ്ങളെയും പരിപാടിയിലേക്ക് സന്തോഷപൂർവ്വം സ്വാഗതം ചെയ്യുന്നു.
First of all, a warm welcome to everyone. Sree Raghavapuram Sabha Yogam Academy is an academic wing of Sree Raghavapuram Sabha Yogam. It aims to ignite the young minds with attitude, skill and knowledge of high order through support system. A positive interference in man-making without profit motive beyond barriers of caste, creed and gender differences. Civil Service Academy, monthly webinars, talks, quiz competitions, etc. are the major activities involved.
ശ്രീ രാഘവപുരം സഭായോഗം അക്കാദമിയുടെ പ്രതിമാസ പരിപാടിയിൽ ഡാറ്റ ദ ന്യൂ ഓയിൽ എന്ന വിഷയത്തെ അധികരിച്ച് ഈ രംഗത്ത് വർഷങ്ങളുടെ പ്രവർത്തന പാഠവുമുള്ള ഡാറ്റ എഞ്ചിനീയർ ശ്രീ ശ്രീലാൽ സാറിന്റെ ക്ലാസ്സിനാണ് നാം ഇന്നിവിടെ കൂടിയിരിക്കുന്നത്.
Once again, we welcome each and every one of you to this event. So, let us move on to the official session. Prayer purifies our mind and takes away negativity. Miss Megha R. Sharma is here for the prayer. Miss Megha R. Sharma is a BA Economics student at Christian College, Kattakada, Thiruvananthapuram. She is a well performer of music and public speaking, who is also an active member of Sree Raghavapuram Sabhayogam Academy Board of Directors as well as Public Relations Department. I now welcome Miss Megha for the prayer.
അഖിലാണ്ട മണ്ഡല മണിച്ചൊരുക്കി അതിനുള്ളിൽ ആനന്ദ ദീപം കൊളുത്തി പരമാണു പൊരുളിലും സ്ഫുരണമായി മിന്നും പരമപ്രകാശമേ ശരണം നീ എന്നും സുരഗോള ലക്ഷ്യങ്ങൾ അണിയിട്ടു നിർത്തി അവികാല സൗഹൃദ ബന്ധം പുലർത്തി അതിനൊക്കെ ആധാര സൂത്രമിണക്കി നിലകൊള്ളും സത്യമേ ശരണം നീ നിത്യം അഖിലാധിനായക തവ തിരുമുമ്പിൽ അഭയമായി നിത്യവും പണിയുന്നു ഞങ്ങൾ സമരാധി തൃഷ്ണകളാകവേ നീങ്ങി സമതയും ശാന്തിയും ക്ഷേമവും തിങ്ങി ജനതയും കൈകോർത്തിണങ്ങി ജനിത സൗഭാഗ്യത്തിൻ ഗീതം മുഴങ്ങി നരലോകമെപ്പോഴും ആനന്ദം നേടി വിജയിക്ക നിൻ തിരുനാമങ്ങൾ പാടി വിജയിക്ക നിൻ തിരുനാമങ്ങൾ പാടി വിജയിക്ക നിൻ തിരുനാമങ്ങൾ പാടി.
Thank you, Megha.
പരിപാടിയുടെ സ്വാഗത ഭാഷണത്തിനായി ശ്രീ ജ്യോതിഷ് സി കൃഷ്ണ അവറുകൾ ഇവിടെ എത്തിച്ചേർന്നിട്ടുണ്ട്. ഇദ്ദേഹം കേന്ദ്ര പൊതുമേഖലാ സ്ഥാപനമായ ഖേത്രി കോപ്പർ പ്രൊജക്റ്റിൽ ഉദ്യോഗസ്ഥനാണ്. കൂടാതെ ആദിശങ്കര ഇന്റർനാഷണൽ ഫൗണ്ടേഷന്റെ എക്സിക്യൂട്ടീവ് ട്രസ്റ്റി, നമ്പൂതിരി പ്രൈവറ്റ് ലിമിറ്റഡ് കമ്പനിയുടെ ബോർഡ് ഓഫ് ഡയറക്ടർ അംഗം, കേരള ക്ഷേത്ര സമന്വയ സമിതി സംസ്ഥാന സമിതി അംഗം എന്നീ പദവികൾ വഹിക്കുന്നുണ്ട്. സഭായോഗം അക്കാദമിയുടെ BOD മെമ്പർ കൂടിയായ ഇദ്ദേഹത്തെ വളരെ ബഹുമാനത്തോടെ ഈ പരിപാടിയിലേക്ക് സ്വാഗത പ്രസംഗത്തിനായി ക്ഷണിക്കുന്നു.
Good evening, people. Thank you, Niranjana, for your kind words. I am honored to be participating in an event like this with an organization with such a great vision, and I feel proud to be a part of it. A warm welcome to each one of you. Thank you so much for offering us your valuable time. We are very pleased to welcome the chief guest of our program, Mr. Sreelal PP, who is an expert in his profession. Sir, your presence has made the event merrier. I would like to express my sincere appreciation to all of you who generously helped us make this event come together to become a success. Well, I don't want to take too much of your time. I promise today will be fun and full of learning. It's a pleasant evening, and I welcome you all to enjoy it with us as we proceed. Now I would like to welcome Sri TV Mathavan sir, Mathavan Nambudiri sir to continue, please. Thank you. Have a nice day to you all. Thank you.
Thank you, sir.
അധ്യക്ഷ സ്ഥാനം അലങ്കരിക്കുന്നതിനായി പ്രത്യേകം പരിചയപ്പെടുത്തൽ ഒന്നും കൂടാതെ തന്നെ ഏവർക്കും സുപരിചിതൻ, അങ്ങേയറ്റം ക്ഷമയോടെ ഊർജത്തോടെ അക്കാദമിയെ മുന്നോട്ട് നയിക്കുന്ന വ്യക്തിത്വം, പയ്യന്നൂർ കേന്ദ്രീയ വിദ്യാലയം സംസ്കൃത വിഭാഗം അധ്യാപകൻ, ജ്യോതിഷ പണ്ഡിതൻ, പ്രഭാഷകൻ തുടങ്ങി വിവിധ മേഖലകളിൽ വ്യക്തിമുദ്ര പതിപ്പിച്ച ശ്രീ തെക്കിനകം വെള്ളിയോട് മാധവൻ നമ്പൂതിരിയെ അങ്ങേയറ്റം ബഹുമാനത്തോടെ സ്വാഗതം ചെയ്യുന്നു.
Namaste. Am I audible now?
ഓഡിബിൾ ആണ്.
അതെട്ടാ ഓഡിബിൾ.
ചിദാനന്ദകലാമായും വന്ദേ ചന്ദ്രകലാധരം നൈർമല്യ ആരമ്യ ബിംബിതാം ചിത്തഭിത്തിഷു. Most honorable chief guest and speaker of the day, Sreelal PP, that I engineer. Sabha Yogam Secretary, Raghavapuram Sabha Yogam Secretary, Sree Hari KP, Raghavapuram Sabha Yogam Academy board members, other distinguished guests, brothers and sisters, salutations to one and all. As we know that Sri Raghavapuram Sabha Yogam is a NGO registered under education, environment and social welfare, culture, and it stands to propagate and sustain dharma, which is the root cause of happiness. Under this umbrella, we have different units, and our Raghavapuram Sabha Yogam Academy is one among them. So this evening, it is very nice because we are adapting to the new situation, and we have to see, we have to look the old things as well as new things, and we have to adopt both according to the situation. So we say that Puranam, Kalidasa, the great poet, says, Puranam iteva nasadu sarvam, tajavi kavyam navamityavatyam, sandap parichandaradat anyadarat prajande, modap paraprattayaneya buddhihi. That means we have to think what is good and what is bad. Since it is old, it does not mean that we should not take. We need not blindly believe that it is new, it is bad. We have to see. So Sabha Yogam Academy, as I told you, that it is aimed to Dharma Sthabana. It is to propagate Dharma, and Vedokhilo Dharma Moolam Smrdishile Tadvidam Ajarashchaiva Sadhunam Atmanastutti. That is from Manusmriti. And it says that the Veda is the root cause of Dharma. If you want to understand, the root source of Veda is Dharma, and also the conscientious recollection of righteous person, conduct of sadhu jana, sajjana. Okay, in the Veda, the practice of good of and learned men we have to follow. Atmanastushtreva, what is satisfactory to our inner consciousness. But it must be Dharma only. As long as it is Dharma, we have to propagate. So this is a very basic foundation. And in the field of education also, now we cannot think a world without a computer, without a modern equipments, and everything now online transaction. Digital India came, and the digital world, one who does not aware of the digital world, he will be naturally pushed down, and he cannot go along with others. So the present topic which we have selected is highly relevant, and I'm very happy that Sreelal is with us. He is an engineer and he is expert in his field, and I understand that he is working in a US-based IT company, and he is a physics graduate and a postgraduate of computer science. And I am sure that all of us will be highly benefited of with his expertise. And with this, I hope that all will enjoy, and welcoming once again all of you. And with this, I conclude my presidential speech. Thank you very much.
അങ്ങയുടെ വാക്കുകൾക്ക് നന്ദി മാധവേട്ട.
Now we are moving on to the most awaited section from Mr. Sreelal sir. Before that, I invite Mr. Vishnu Nambudiri Varanakod to introduce our chief guest, Sri Vishnu Nambudiri Varanakod. He is a technology leader with 2 decades of global experience, true sportsman and social innovator. He focuses on sharing the earnings and learnings to youngsters. Welcome you, sir.
Thank you, Arjun. Thanks everyone for joining this monthly session of Sri Raghavapuram Sabha Yogam Academy. So every month we try to bring some new topic which is our students and everyone in the community, and what can help them grow as a good citizen of the country. So in this session, we are currently living in a data which will increase in the coming years in multiple ways. As we know, it is happening already around us. We are all part of the data revolution that is already happening. So at the Sabha Yogam Academy, what we think is that it would be a good idea to know what is really happening. Most of them may not be knowing what is at the ground level, what is happening. So this session is to really give insights into the topic of data and what is happening around us across the globe. That is why we invited our chief guest, Sreelal, who is working in this area for more than 1.5 decades now. So he has been helping large companies building data warehouses and analytical and reporting solutions. And he's also very passionate about data, if you look at his profile. And he has been taking sessions for some of the school students in Kerala recently, or also during the COVID lockdown times. So we had a catch up 1 month back, and we requested Sreelal to come and present his thoughts about data in this forum. And he is a science graduate. He graduated from Sir College in physics. Then he took the computer science from Calicut University. And he is from Raghavapuram in Kannur and currently living in Bangalore. He is married to Ramya, and also he is blessed with 2 kids, Tanmay and Tanvi. So I would like to request Sreelal to give your insights to the audience. Thanks. Welcome, Sreelal. Over to you.
Sure. Thank you, Vishnu, for the detailed introduction. I'm very happy to speak few words and few words about the field that I'm working on. So before I get started, I'm audible, right? Audio is clear, right? Vishnu?
Yes, Sreelal.
All right. Yeah. So before I get into the details, I just wanted to set few ground rules or some basic details that I wanted to share with you. So first thing is about I'm not a speaker, or I'm not someone who takes classes or anything. I'm basically interested to talk about the field that I'm working in, and so it will be more of an informal session, more of a very collaborative session where I expect you also to be part of the discussion, share your thoughts, ask questions. It's not just me. I know Vishnu also has been working in this IT industry. Though it is not specifically in the area of data or data engineering, Vishnu also has been working and leading a lot of IT projects And we were basically, I just wanted to call out that we were, classmates, where we started early 2000, where we were staying together in a room, and Vishnu, I remember he used to start coding at that time using his old Java book. It was like this much big Java book, and he used to sleep in the book itself. Basically, he even used it as a pillow, because he is like even now he is a continuous learner. So what I'm telling is, like, this topic is not specifically, you don't need to think it purely on a data perspective. This is more about an introduction to data, and you can always relate data engineering with a lot of related technologies, which most of you are familiar with. So let's make it more collaborative and more informal, and make use of the session in the best way, best possible way. So I'll also be going into very detail. I'll not be going into a lot of technical details. I'll not be going into a lot of technical details. I will try to make it simple and meaningful for everyone in this meeting. So thanks once again for this opportunity, and let me share my screen. Let me know if you're able to see it. You are able to see this, right?
Yes.
All right. Yeah. Thank you. So the title that I've selected is Data, the New Oil. So this is more of a fancy way of introducing something. Data, the new oil, and we will talk about how data, or why are we calling data the new oil, and how is it related to oil. And we'll also talk about some of the details around this data management, what is happening in this world of data engineering, and what are all the job opportunities, and where this overall IT as a profession or IT world is heading towards, to meet this emerging, or this exploding, day by day exploding data. So that's the whole topic that we are trying to cover today. So obviously the basic question, or the fundamental question that we have to start with is, what is data? And I'm sure all of us are familiar with data. It's not just the people working in IT, or it is not just the digital data that we talk about. So everything is data, right? Everything is data. So if you look at more of a technical definition, like a theoretical definition, what is data is nothing but the collection of facts, right? It could be numbers, it could be words, pictures, measurements, voice, or whatever. At the end, it's all a collection of some information in some way, in some format, okay, in some way. And why is it relevant? Because we can use it, we can use it to derive some information. We can use it to derive some meaningful insights, or some meaning we can derive out of it. So it could be anything. It could be numbers, it could be, pictures, voice, whatever, right? So when we say it could be anything, say, we just make a list of items for our shopping, right? So we are going to a shop. We wanted to buy a few items for our home, and we make a list, like, say, some grocery we wanted to buy, or something else. Say sugar, one kg of sugar, milk, 2 liters of milk, then whatever, right? So you make a list of items that you are planning to buy from a shop. So basically what you are noting down, and what you are actually representing it in a piece of paper is data. You are talking about an item and a quantity. So sugar is an item, and 5 kg is the quantity that you are planning to buy, and you're just putting it in your pocket. That's one way of representing data, one way of storing data. You are storing it in a piece of paper as a manual text, a string. So in a simple term, that is data, in simple terms. But that is purely a manual data, or something like an analog data, right? So where you write it, and you cannot really use it in a lot of ways other than you can just read it and buy items from the store. But think about representing or storing this data in a digital format. That's what we have been doing using computers from the early ages of early ages of computers. We represent data in digital format. We'll go through it in a little more detail, but in digital format, we are actually saving it in some kind of a digital technology or a digital platform. Right? It could be a tape, it could be a disk, hard disk, or it could be any kind of a storage mechanism. So the main difference between the analog data and the digital is forever. Right? You can always move it as is into another platform. But an analog data, to give a better example, think about a bank, right? All of us are familiar with banking, and we go to bank for our regular transactions and for depositing money and withdrawing money, and for all other purpose we visit banks. Right? Think about a bank functioning of a bank in early 80s, how it used to be. I know most of us are familiar with similar situations or similar examples. Banking is a simple example where, say, in the early 80s, without computers, how banking used to happen, like large set of ledgers and lot of account books and accounting. People will be writing, and imagine how they used to tally at the end of the day. They need to tally the whole transactions of the day. They need to see how much of payment we have done, how much money we received, how much loan we paid, how much. Now, every transaction happening in a bank or in a post office or in a school or in any organization has to be audited, has to be tallied, has to be stored for future purpose. And you can imagine how, we all know how tedious was it. Say after 2 o'clock the banking will not be there, because after 2 all the employees of the bank will have to work for closing the day, writing down, taking the totals, and storing it and preparing reports and everything. Now that the banking has become like a 24 hours available service for us. 24 hours available, it's within our fingertips, right? It's within our mobile and app, where we can always do a transaction, we can always send money, receive money, we can always see our reports and everything. So the main difference is the way the data was stored and the data was processed. One is analog, other one is digital. So this is just a simple example of how the analog data and the digital data is changing our world. Just an example for a banking. So we'll get into more details. In a simple line, whatever I told, like data everywhere. Any aspect of our life, let it be your any day-to-day regular life, you deal with n number of situations where you interact with the data. You produce data sometimes, all of us produce data, or we consume data. So produce data means like we message in WhatsApp, right? So we send a text message. It's a data. It's a digital data. We send a voice message. What I'm doing now is again another way of data, right? My voice is being transmitted through the internet as data packets delivered to your digital platform, your equipment. Let it be a mobile or it could be a laptop, whatever. And I know Vishnu is saving this, right? So he is actually storing the data, the continuous stream of data which I am talking. It's like a flow, right? So continuous stream of data is being saved in some, in Google server somewhere. I'm sure it is in the US. In some data center it is stored. And say later someone, after a couple of days, someone else wanted to view it or listen to it. They always retrieve it from the storage, and we don't know from where it is coming, traveling all the way from the data center in the US to our living room, our mobile in our hand. So it's there everywhere. You go to a supermarket, you buy items, they scan, they produce data. The transaction is recorded in a supermarket. You log into your banking account, you make a bank transaction, your transaction is stored. You go to school, make an admission, say, for example, you make a fees payment, your transaction is stored. anything for that matter. I'm talking about our individual, like a layman's day-to-day life standpoint. What are all the touch points that we deal with? You send a voice message, it's a data. You upload a video in YouTube, it's another data. You buy something from an online portal like Amazon or Flipkart, it's another transaction, it's another digital transaction. The data is being created and stored. So it's everywhere. It's everywhere, and we are already started dealing with it in one or the other way. A simple example of a supermarket or like a departmental store where we go and buy items, right? So when we go to a supermarket, think about we make a small purchase, we buy some vegetables and we make a payment. So the whole transaction is being recorded. Think about the same transaction on a larger scale, right? A large retail company who has hundreds of stores. Every second, every minute, hundreds of transactions are happening. They are receiving goods from the vendors. They are selling items. A lot of transaction is being happened within every second during their business hours. So everything is digital now, right? It's not just the point of sale or where you pay, or the place where you make a payment. It's not just one device or one area is being digitalized. Everything is digitalized, means your back end, your inventory, your vendor interactions, everything is digitalized. So there are a lot of data is being produced by every organization. Retail store is just an example. What do we do with this data, right? So obviously the objective of every business is to make money, right? Or to grow as an organization, provide better service for their customers, for their their partners, vendors, pay a better or make a better working space for their employees, better convenient, meaningful space for them. Right? That's the objective of every organization. And to take decisions to drive their business, they certainly use this data and they need this data. The same example where we just spoke. One second. Is my presentation visible now? It is visible,
Yes,
right?
yes.
Yeah. Okay, good. So this is just a dashboard of a retail business. As I told you, a retail business, a supermarket business, in simple terms, will have n number of departments. They will have a department of inventory, sales. They will be interacting with the vendors. They will be interacting with the factories where the items are produced. Transportation will have to happen. They will have deliveries. They will have interaction with competitors. They need to price the product at the right pricing because they have competitors and they have to make sure that the pricing that they do is best in the market. They need to understand the location. They need to understand the customers to serve them better, the demographics, point of sale, employees, and whatnot. Like there are hundreds of such areas within an organization. So when we see at a high level, we feel like we just go and buy things, but behind the screen there are a lot of departments behind every organization. They use data for their business. The pricing, the sales data will be used by the sales department to measure their sales. How are we performing, right? And at the end of the day, we need a meaningful, presentable place where we understand the data. If you give a big ledger of say 200 page to someone, say that, hey, this is my transaction data, this is all we have, it is not meaningful, right? A leader or like an organization, someone who is running an organization, to make some decisions, to understand where their business is presently, they need meaningful insights. And that's what that you are seeing here. In a simple terms, they are actually aggregating all their transaction data and trying to build some kind of a dashboard. Like say, for example, sales by division, like how many or how much sales we are making in the women department, men's, kids area, sales by city, out of stock, what percentage of items are out of stock, during what period of the time, so that they can always plan better, right? Obviously, during festival season, they need to have more stock, so they can always identify where they are lacking in terms of stock, pricing, a lot of details. So I'm just giving an example how data is being used by a simple organization like a retail. Another view. So what are what percentage of year to year growth, right? Compared to last year, how much percentage our sales has grown? How much units we sold last year? How much profit? So this is something like a dashboard the business leaders can use to decide or identify where our business is presently. Now, how are we performing in each zone? For example, see east, west, south, north. One is about actual and the other one is target. So we planned for this many units of sale, and this is what we actually achieved. So just an example how we are using it. Let's take a step back now, right? So we have been talking about presently how are we using, but let's take a step back and see how, where did we all start? The history of data, a brief history of data. I'm always curious to know about the history of everything. So I was actually trying to understand what are all the early, proof that we have where we saw data, represented. Just take another example is about the history of computers. So whatever, 19,000 BC is what I saw. This is again taken from Google's one website, which I can show you later. So this is something like they call it as a tally stick. A bone of an animal where these marks, whatever marks you can see, it's actually told that this is the first documented record of storing some data, numerical information stored in some kind of representation for later usage. So this is what I found as the first proof of how we stored data, or in another simple term, this is the first storage or hard disk or whatever, right? It's in a bond. Then we started, right, as the human started evolving their whole life. 1600s, we passed the whole history and we reached 1600, where we started about the interpretations of data, one of the earliest available recorded instances of data analysis. So data needs to be analyzed, as I told, right? To make some meaningful information, we need analysis. So this is one of the example where in London, the death rate of people were tallied, and they were trying to find out some meaningful insights about like genders and life expectancy and all those things. So it's in 1600s, early 1600s. And that was the problem of a data analysis. And later, 1800 is when we actually started thinking about devices like machines, like mechanical machine devices, which will do something, some repetitive work that it is really hard for human to do. And this is the first the tabulating machine, and it is actually in 1880 created for this US census. So I was actually reading in detail. So what happened is in 1870 the US census started, and it took almost 10 years to collect this whole data and try to tabulate it to get some meaningful information. So it took 10 years, and that in 10 years the whole demography will change, the whole numbers will totally change, right? So it was not really useful. So in 1880 they brought up a competition for people to come up with some kind of a mechanical device to make it simple, and that is what this machine, Herman Hollerith, it's called the Hollerith desk. It used the punch card to calculate, to count the data, to tally the details. There is a video also related to that. I think I have kept it open here. Yeah, it's one of the early machines. And
name, address, etc. And this is all we put into numbers on this machine. And I can't use this particular card because it has been used all the little holes, you might see them. But this would gradually, the more I did this would gradually, there's a card being pushed in. And as I transpose everything into reading this, remembering the numbers, this is a spacer like a typewriter has, and this is working its way back. And the card would eventually come out at the other end, finished, and you turn your card over, and you turn the page, and to see what the next invoice contains. But sometimes you would need a few cards for one order, and it will be very carefully kept in place, in order, ready for the verifier to go through all your work. And if her machine hit the wrong space, it was wrong. So,
Oops. I lost a connection in between.
Okay, Srila.
Yeah, give me a second. I'll connect back. Give me a second, please. Vishnu, can you share the screen?
One second, let me start.
Yeah, I think we.
good afternoon. My name is.
Yes. Audible now, right? Yeah, so we were talking about the history of storage. Right? I think the previous slide where we saw some of the early in 1800s data processing problems. So this could be the first or the first computer, not the digital computer for sure. This is the kind of a mechanical device. Move on, Vishnu. Right. This is another question of storage. So as we progress, the question started coming about the storage of data, right? So we can't use this punch cards, or we basically we need some kind of a mechanical or some kind of an electronic device to store data. And this is the beginning of that era where we started storing data in the form of, or storing data in disk drives and floppy disk, things like early 60s. So this is the age, or this is the time in early 60s is when we started thinking about more of a structured data storage. Right? How do we store data in a digital format, and how do we retrieve it, and what are the basic infrastructure needed to do that? And the 60s and 70s is when we started the relational model of data. This is what actually the beginning of the whole database systems, DBMS, whatever that we see use now, right? So that's the place. Move on, Vishnu. Moving on to the 90s, 80, 90s, that's when we moved on to an era of our internet, where initially it was for the US government organizations to connect and share information within their organization. But later in 1983 is when the first protocol, what we call the TCP/IP, 1983 January 1st, and usually that's the date we call it as the the birthday of internet, because that's when the protocol was first defined and people started using, 1983 January 1st. So it's 40 years right now. Yeah. Move on. Growth, we don't have to call it out. All of us know how fast the internet is growing, how fast the information is being spread in our world. So the growth simply indicates how fast we are all. So all of us are now literate with respect to the usage of internet. So that we don't need to talk about it much, right? So we can go ahead. Okay, so we were all talking about this till now, but the question is about where is the oil, right? Because that was what our topic for the day. Where is the oil? The oil is here. Right? This is a simple picture, and where you can see companies named, like companies that you are already familiar, like Amazon, Microsoft, Google. They're all digging something from the rig, right? Which is nothing but a symbolic representation of how these organizations are mining data, which is around us, right? Not just around us, within any organization. So a simple representation. So move on. So it's not a new term. So the data, the new oil. This term was actually coined in 2006 by a British mathematician named Clive Humby, and he just coined this term usage called data the new oil. And why is it like that? You can move on, Vishnu, and you don't need to talk about it, right? So we know that in the history of our mankind, the major revolutions like industrial revolution, then electronic revolution, then later the internet, the whole digital revolution. So how the mechanical revolution or the industrial revolution helped the industrial economy growth in 1800s and 1700s. Similarly, the oil helped to for a big hype or a growth in terms of the economy. Similarly, the data is also fueling the information economy that we are presently dealing with. One is oil is a natural resource, we know, right, and which is available, abundant, and similarly, data is also around us. So we dig information from data. because if it is just data, it is not useful. But similarly, we get our energy from oil. Both are valuable, right? How much valuable is oil? We all know. Similarly, how much valuable data is what we are uncovering now. One is finite resource, another is infinite resource, and data flows like oil. I mean, it has to be extracted from somewhere. It has to be processed. It has to be distributed to some place to make it useful. Similarly, oil, right? We extract oil, we refine it, and we deliver some value out of it, some kind of an energy out of it. So this is how it is being compared. More than the similarities in terms of this usage and everything, the value is what matters. How much the oil helps, or how much value oil has in our life. And similarly, the data is also highly important and equally important for every organization. Move on. Okay, they got it. So we learned that, right? We learned that data is a new oil. We understand it has a value. But what is the problem? And that is where the term, or that is where the data engineering is relevant. And the problem is big data. Maybe few of you are familiar with this usage. And the term is big data. The data has gone big. It is massive. Not just big, it's huge. You can see how big is our internet, right? So within a minute or in a day, in a minute, how many transactions are happening around us, around the internet. You can see the picture, and this is what you can. I'm not sure if you're able to read it properly. This shows how much transactions are happening around within the internet. So Netflix, YouTube, Facebook, Instagram, Twitter, a lot of digital platforms, Google. How many searches are happening? 15 million searches are happening in a minute. I'm audible now, right, Vishnu?
Echo on this will.
There is an echo. Give me a second. I don't know what's
Sorry, I'm unable to hear.
happening. Now?
Yeah, no, it's clear. No, it's clear, loud and clear.
Okay, perfect. Let me share my screen here itself. Vishnu, I'm back here. Is everything okay now?
Yes.
Okay. All right. Here we go. So we were here, right? The problem is big data. In a minute, how many transactions are happening, and what do we do with this massive amount of data produced, right? So if you are uploading 240k photos in a minute, 240,000 photos in a minute into Facebook, how does Facebook handle this data? Or how do they manage storing this data? And once you upload, in the next moment, you will see people liking, commenting, sharing, and how Facebook is bringing this whole massive volume of data for its users without a delay of not even a microsecond, right? So that is what the term that we just spoke about, big data. Not just the case of Facebook. Look into any transaction like Amazon. You can imagine how many packets are being sent over, or orders are being placed in Amazon. How many transactions would be happening in a bank? how many transactions would be happening in a stock market. That is the problem, and that's what we call it as a big data. And the major highlight of the big data, or the major challenges of big data, is in terms of the volume, the velocity, the variety, and the veracity. We usually call it as 4 V's of big data. Now it's not 4, it's 5, 6. I've seen a lot of different variants. So in simple terms, the volume of data has grown massively. How small data we used to have in CD drives or floppy disks in early 2000, right? And now we are no more seeing such terms. We are all talking about cloud storage. So the volume has grown massively. Thousands of review comments are being floated within few seconds after a movie is released. Right. So the volume is too high. How do we handle? That's a challenge. And the velocity. Velocity means the speed in which data is being produced. Think about sensors that are sensors, right? So take the case of an automobile, a vehicle, a car that we use. Everything is digital, and every moment the car, every sensor within the car is recording the data. So when you give your car for service, they just connect and just read the whole data: how many kilometers it has run, how many times the brake was applied, how much of fuel it has consumed, how much of mileage it has done, how many accidents it has made. Everything is being tracked in digital data. I'm not talking about a high-end sports car like Ferrari or something like that, but I'm just talking about a local small car that all of us use at our home. So the velocity of data means terabytes of data. Say here is a simple example, right? So trade information. Terabytes of data is being produced in every second. When we need infrastructure, we need hardware, we need software to handle such a flow of data. Variety, another term, right? So variety of data. It is not just a text information. It is voice, images, text, videos, and whatnot. A lot of variety of data has come, and we need infrastructure, we need capability to handle such data. Veracity, we get a lot of uncertain data, poor quality data, incomplete data. Okay, so and we need devices, we need technology support to handle such data. Just showing how the scale in which data we represent and in what phase we are now. We are talking about petabyte of data. Terabyte is, everyone, all of us will have a terabyte of hard disk, right? 1 terabyte of hard disk, 2 terabyte, and organizations. Challenges: volume, variety, velocity, multiple storages, quality of data, lack of process and systems, integrating data from all these different environment and platforms, lack of skilled resources, governance of data, certainly privacy matters, right? So every data is not public. Certainly there is a level of privacy that has to be applied out of data. Health data, for example. So national or national or government official data, another example. We need security. We need automation to process the data, and we certainly need analysts to process it. And so this is the challenges, and this is where see data as a opportunity for IT professionals. As I said, capture the data, manipulate it, extract insights. These are the 3 phases of, or like a life cycle of a data. Capture means we need to capture it from different systems, from the company. If you take it, a retail organization, from their sales systems, their counters, their HR applications, their sales platforms, their online portals. Capture the data, prepare it, and store it in a storage which is easy to retrieve. Manipulate it means use this data to get some meaningful insights. run your statistical model on top of the data, analyze it, and use it for some meaningful information, and monetize it. Monetize means like get value out of it. That is the whole life cycle of a big data system. In another way, looking at it, the raw data, the base data, which is nothing but unorganized raw facts, which gets into an organized way. We call it as information. So you can see in the right side an example, right? So raw facts, something is being written, something is noted down. And if you see the next picture, we just structured it, make it in a more of a meaningful information. First service, then how many seconds it was down, minutes, hours it was down, on what date. So that's what we call information, which means it has a context. Moving on, information is being refined to knowledge. Means some meaningful information. And so from here, from this information, we are able to relate some meaning, right? How many hours the service was down, and what is the loss and profit, things like that. So that's knowledge. And from knowledge, you further define it, you apply your machine learning algorithms, your statistical models, and make more meaningful informations, and which will help you to say that, okay, if I continue to be like this, what will be our future? Basically, it will draw conclusions and help making decisions. And that's what you can see, call it as a wisdom. So data to information to knowledge to wisdom. That is the track that we are actually, following. I'm not going to details of this. This is an example of how a kind of a retail platform, a retail store is using the data to make meaningful decisions, right? Where to keep what item. If you keep, what item we need to keep together so that we get a better sales. How do we optimize the price? How do we expand it to, the local demand, right? You don't, if you sell the same item in every store, doesn't make sense. In some area, you will need a different items. If it is depending upon the weather, for example, right? So, example, how did we do this? And at the same time, we also have to make sure that the data that we deal with is of pure quality. It should be accurate. It should be complete. For example, completeness means when we say yesterday's sales was this much, it should be the whole day's sale. And we can't say that, okay, till 5 p.m. this is the count, and after 5 I don't have data, which I'll give tomorrow. Which is not useful to say, count it, right? So completeness, data should be consistent. It should be timeliness. So simple example is a bank transaction, right? So there is a fraud transaction happening in your account, and you need the data immediately. The bank need the data immediately to identify, okay, was that a fraud transaction or not, right? Or to take some immediate action to either to block the card or to block your account. So timeliness matters. So it should be on time. Similarly, valid. It should be specific format and unique. If there is a one transaction with one transaction ID, that should be unique, and you will never expect the same transaction ID tied to another transaction. So it should be unique. How we as a data warehousing or data engineering project will execute. So from different data sources we capture data. It could be structured, semi-structured, or unstructured data. Convert it into meaningful insights and use a lot of DW tools to present the data. Another way of looking at it is the evaluation of business, and we call it as a business intelligence, right? So BI as a reporting, then self-service, and AI, artificial intelligence enabled BI. So previously it is like, why did it happen? Diagnostic way of looking at things. Then it is predictive. What will happen if I continue my sales like this? And prescriptive means what should we do to avoid some situations. So this is what we call it as a data-driven decisions. The decision is made using data, not just by nothing else. Why technology, or what is technology struggling to meet the situation? As I told, any platform, any solution, any software, hardware that we make to meet this data explosion has to be cost effective. It should be high performance computing. It should be fault tolerant. Something failed, it should be able to catch up on a backup server. Right? No bank will, or you will not, tolerate a bank who is saying that, hey, my server is down and not available. Who will tolerate? Even if your WhatsApp is down for half an hour, if YouTube is down for 5 or 10 minutes, you will not be able to tolerate. Think about a company who is running a business and say that, hey, my business is not, my platform, my data is not available, my portal is not available for 5 minutes or not even for 5 seconds. So technology has that challenge to make it fault tolerant, high available, always available, 24/7. Think about a train booking ticket, IRCTC train ticket booking, right? So, right, it should be available 24/7 for everyone to book ticket. High throughput. Similarly, the important thing is about open source. The technology should be available for everyone to learn, use, and contribute. That's where the space of open source comes into this one. Scalable. As in day by day data is growing, we can't buy one computer, one whole server and throw it by another one, right? So we should be able to scalable, add and more nodes in the system. End of the day, usefulness, ease of use, everything. I know I am taking more time, but let me quickly go through the different areas. Like customer analytics, use the demographics data to identify in which demography, what kind of people are living and what kind of need they have, right? And their behavior, their social, their personal, their age, their every attribute of a human is being used to identify who is the right customer. Industries use it. Business process, certainly to identify the employees, efficiency of their process, logistics, transformation. Telecom, another simple example, another best example for industry, right? Think about how many phone calls, how many messages are being sent over internet in every second. So to identify, companies need infrastructure to manage this data, they need infrastructure, they need solutions, softwares to identify what is the right plan, what is the right service, what is the right package for your customers. Because by looking into the transaction pattern only, they suggest, right? They identify, okay, if I sell this particular package, it will be more profitable compared to the other one. Travel and tourism, another example. Before we travel, I'm sure all of us at least search for that particular location and find out what is available there, what is the package, how do we compare different packages. Media, simple example, movie. We're all using OTT platforms for watching movies, right? So Netflix or Amazon Prime, whatever, they are all providing continuous streaming experience, and behind the screen it's nothing but data. Healthcare, simple, best example to talk in this era of pandemic, where we deal with a lot of pharmaceutical research and a lot of official government and non-official data being produced. Remember the Aragya Setu app, right? So if you look at it now, you can see a lot of reports which will tell how the whole vaccination drive was executed, how many people are being vaccinated every day, what is the areas in which the whole drive is happening. And remember in a year ago, right, how the whole pandemic is being spread, we were able to see it through an app. It is nothing but data behind the screen. Education, and we all use online platforms for education. Even the talk that we are having now is on our online platform, and how it is. Retail, another example. We already went into the details of retail, about how retail companies are using data to get some competitive advantage in their business and understanding the customers. Loyalty programs, right? So loyalty program is not every customer is getting the same offers. When they go to a store and buy something, and by the time they reach the checkout counter, they have a personalized offer, and that offer is based on their previous history, transaction history, and data needs to be at their fingertip for these applications to provide some offers so that they retain the customer, they make more money out of it. Demand and sales forecasting, what is to be brought into a store looking into the data. Finance and banking, no need to call this out. Stock market, banking, insurance, any trading or any other financial platform, highly used. They use a lot of big data solutions, a lot of data engineering platforms to manage their risk analysis, fraud detection, any trading or any transaction requirement. Supply chain, the item that we are producing in one country is being shipped to any large network and sold it in another country. Tracking, sourcing, shipping, warehousing, everywhere technology is used and everything is dealing with data. And this is where data engineering as a job market evolves. This is where we understand, or we know that, okay, there are more and more skilled resources, skilled people, skilled engineers, skilled statisticians, mathematicians required by the companies, by the industry to get value out of this data. So what you can see on the screen is the set of job roles or positions that are presently available or presently in the job industry, in the job market, IT job industry. So we need analysts to analyze data. We need engineers to source the data, process it, and store it. We need database administrators to manage the whole database. We need artificial intelligence and machine learning engineers to predict the future using algorithms. We need data scientists. We need data architects who build the solutions, who define how a particular solution should work. We need statisticians. We need analysts. We need a lot of managers, engineering managers to manage the whole thing. We need developers, modelers, product owners, and whatnot. So what I have listed here is a set of job roles and what is their skill set. What are we expecting from them? What machine learning engineer is supposed to do, what a data scientist is doing, what a data architect is doing. And if you look at the company and organization, it is not just one person doing everything. It's not like a software developer will do everything, right? It's a set of skilled, experienced people sit together and develop softwares. Business analysts will have to tell, okay, what kind of software is required. Data analysts will say how the data should be prepared for kind of analytics. DBAs or database administrators will ensure that the data platform is up and running, always available. And a lot of other skilled resources will be there around. CDO. I know most of us are familiar with CEO, Chief Executive Officer, or Chief CFO, Chief Financial Officer, CTO, Chief Technology Officers, right? These are all called C-suite, where the topmost layer of any organization, any company, CEOs, CTOs, and we are all familiar with that. And I don't know if you have noted, now there is a position called CDO as well. CDO is nothing but Chief Data Officer, not Chief Detective Officer, as you can see here. Chief Data Officer, a lot of companies are now have a position at the top layer called Chief Data Officers, which means data is part of their a strategic, what you call it's like an asset, right? Just like employers, just like employees, customers, equipments, everything, data is also an asset, something like a very critical key resource of any modern organization. That's why we started seeing CDO positions in a lot of companies, chief data officers. What skill is required for a data engineer or like a student who's actually stepping into a career in IT, or a student who's actually doing their science degree or engineering degree now, where they can focus? Java, Scala, programming language is certainly required skills. Python are highly used now in the industry. So you need programming language skills if you are planning to become one or the other. So if you look at this example, right? So it's not just someone who can directly become a data modeler or someone who can directly become like a data architect. Most of the profiles, most of the positions are now started as a simple developer who has the basic knowledge in all these programming languages, some hands-on experience, and later you choose, depending upon your interest, in what area you wanted to excel and what area you wanted to build a career. It could be as a database administrator, or as a manager, or as a continue as a developer, or as an architect, or a AI scientist, artificial intelligence scientist, or any area. But most of these technology, most of the skills are required for any engineering or any science student who is actually planning to build a career. Data warehousing skills, this is more specific, and I don't really think this is highly required, because this is changing every time. This will be changing. Quick glance into the open source area where technology is available for each of the areas within data engineering, like machine learning. These many open source technologies are there, where you don't need to invest or you don't need to buy any softwares. Everyone can learn and contribute. Machine learning, search, security, data processing framework, Hadoop. I know some of you have heard about Hadoop. Very popular and highly scalable platform for high massive data processing, storage and processing. So Hadoop is there. Then query processing, coordination, real-time data streaming and everything like Storm, Spark, highly used. Statistical tools like R, Scala, and Python as a programming language, highly used. Before we close the session, this is a picture, or we usually call it as IoT, right? Internet of Things. This is something like a future state. We are already there, but you can think it as something like a future state where every device that we deal with is connected to the internet. In one or the other way, they start interacting and they get instructions and they get transfer data through this network. I know, as I told, the cars, the automobile industry is already creating, has a lot of IoT devices and sensors and things like that in their devices. Similarly, every area is being smartphones, smart homes, cities, right? Energy, your watch, wearables, your health, home appliances like your refrigerator, anything, farm, agriculture, everything is going to be smart farming, where you start regularly measuring the humidity of your nature, your area, the water presence in your soil, the contents of your soil. Everything is being monitored and stored digitally and connected. So what I'm trying to say is that these are all opening up a lot of new opportunities for data engineers and the whole field of data storage and processing. So certainly there's a lot of scope for all of us, for all the students, okay, to invest and learn data related technology and find a very rewarding career, highly rewarded career, in the sense, in terms of the salary, and in terms of the opportunities, in terms of the learning opportunity that they have. A lot of things are there. I just don't want to limit data engineering as a job profile, like a salaried profile. I also want each student who is actually listening to this program, listening to this session, to think about, being an innovative entrepreneur who understand the value of the data, who build systems to help companies to, or build your own, products to help, or build your own idea, your own products to get value out of this emerging data technology. So I have given some references here for computing history. If you are more interested about the history of computing. Another interesting thing is about this artsandculture.google.com. I'm not sure if how many of you have seen it or used it. If you go to this artsandculture.google.com, and there is an app also you can install. If you are interested about history, there are a lot of very informative details available. Right. So, or you can say computer. But for it, you will see, you can see a lot of museums and everything, and by going through this, and also you can see the evaluation of, computers, history, your disk data in a very informative and very meaningful way. So you can go through the exhibits in their museum and go through it. This is useful, highly useful if you're interested about the same holographic electric tabulating machine, what we just spoke, right? So you can go through. Very good resource for people who are interested in arts and culture, not just electronics or not just computers. If you look for search for any other area, you can always see the details. Right? So, for example, theme, and you can see the famous museums where these exhibits are stored, and you can explore these things. Again, this is all digital data that we are seeing, and yeah. A lot of unseen, unheard data is available in this particular Google Arts and Culture website, and you can always take a look at it and get some more details around it. I think I am done with what I wanted to cover as part of the session. I know we took more time than we initially planned. Any questions, Vishnu? Anything that we wanted to talk more or?
Sreelal, I think there were two questions. One is already answered. There's a second one about the chanting of Veda. Why do we need to chant even if there is printed and also digital form? So I would request Hari to answer that. I may not be the right person to answer that.
Yeah. No, I can add one line to it.
Yeah, please.
So one is about computers, right? So computers process data, right? And it takes some raw data from it, and it processes, and it creates some meaningful information out of it, right? So we write programs to do that. We write complex algorithms to do that. We write complex programs to process that particular data. The example where you can say a sloka, right, or like anything for that matter, like a poem, and the biggest processing engine is our brain, right? And we need to read it, we need to process it, we need to get the essence out of it, which is nothing but what we are calling insight, right? So in terms of we spoke about the insight from a retail company standpoint. So this is more about an insight from that particular text. It has a different value, it has a different aspect. But what I'm telling is, like, there is also data processing is happening. We're trying to understand the meaning in different ways and different aspects, and we are trying to get value out of that particular text. So that's how I see it, and certainly you can add, Vishnu.
Thanks, Sreelal. I think that is one question that is very specific.
Mhm.
That what is the need of chanting Vedas? I think we will request the experts to answer that. Hari, could you answer that question?
Hello, everybody. Am I audible?
Yes.
Yes, Hari.
Hi, Sreelal. I also have a question. And in between last 5 or 6 minutes, I couldn't hear. I was in another meeting. I had to join there. So sorry for that. And this question, I can answer with an example. See, music, you think of music. You know, music that enjoys us. We all of us like to hear music. Suppose the same thing, same music that we hear, a movie song or any song, classical song or something. Suppose we are just writing it in a paper and showing it to you. How do you feel it? Will you get the same enjoyment as you hear it from Yeshudas or some Carnatic musician? It is totally different, right? Same way, it is a different perspective. In Indian culture, it is a holistic view. Vedas means it is not just letters or just even not just sound. It has many aspects associated with it. That is, Veda and Vedic Dharma are different. And in modern view, or you can say Western view, Vedas are printed. They are read by everybody. The meanings are captured. Meanings are written in many ways. But in Indian tradition, or we call it as Sampradaya, it has some restrictions, and some rituals are to be done for following Veda or even chanting Veda, like that. So there are different perspectives. That's all. Vedas can be printed, Vedas can be read. That is one perspective, and it is to be learned and it is to be chanted in a restricted way. That is another perspective. So up to us how to decide it. And I have one question to Sreelal. Can I?
Sure.
Yeah.
Sure, please.
The question is, as of now, we have lot of sources of data, as you told in the beginning of the presentation itself. So excessive data, actually. So how to manage it? Because now itself, I am the secretary of Sabha Yogam, handling so many departments. I'm getting lot of data, lot of information from various departments, and total there are 24 hours only. So we are finding it difficult, little bit difficult, especially when some people are not performing to the level. So in future, what I see, all organizations are they have to handle a lot of data. So day by day it is increasing, the level is increasing. So what will happen in the ultimately what will happen in the future? That is my question. How it will affect the human being? Still, suppose see this session itself. We have done so many IT works before this session. We spread the word in all social media, but there are only less than 25 people who attended the session continuously for 1.5 hours. The same result earlier we used to get just by our direct connections. So are we actually benefiting out of this much of data or this much of information, this much of work? That is my question. Might be a foolish question, but
No, yeah. No, certainly not a foolish question. And I don't have a specific answer to that question also. What you are saying is absolutely right. Excessive data is one thing, and also junk data is another aspect of it. Excessive information is one aspect of it, and a lot of junk data. So that is one of the challenge from a IT, organization standpoint, or from an enterprise standpoint. That is one of the biggest challenge that every industry is actually facing. So we, if you, I'm talking about a large scale data handling standpoint. So we call it something like a data lake nowadays, where data is continuously flowing and getting accumulated in a storage. And we certainly don't need everything. So we have separate programs, softwares to identify what is relevant, what is required, and we pull only those information to our processing area. So if you bring the whole data into your application, it's going to crash. So if you land whole review of a particular product or a movie or whatever into a particular reporting solution or a platform, it's going to crash. You just take, you understand the data, you mine the data, identify the meaningful insights, get the, if you are analyzing the emotions from review, get only that final product and present it. That's where the whole challenge is with the technology to enable. And that's in another way, that's a big data problem that we or like the data engineering and engineers and also the technology infrastructure is actually trying to solve. Vishnu, you want to add anything to that?
Yeah. So Hari, that is a fundamental problem we are also facing. Any organization like we are, ours is also like 160 years, and we use just 2% of the overall data available for our decision making. So the data is too much, and we cannot, as a human being, we cannot understand or process most of this data at one time, right? So what we normally do is data as a service. So we have all the data available in a lake that Sreelal mentioned, and based on the need, we need to have a view of the data. So that is where all these technologies are really helping us. So we have different types of open source technologies. Even if you look at the Sabha Yogam, we would have collected n number of artifacts and documents and reports and events and everything, right? So there are tools available which can be used for the right purpose. I think that's what we need to do. Like we switch off the phone when there is another meeting or something happening, right? Like that, we have to turn off our inputs when there is no need and use the one that is only needed for a particular purpose. That is where all these technologies can really help us. That is what we are also using in the industry at the moment. So sometimes the human cannot, even with technology, we cannot help. That is where the artificial intelligence and the machine learning, it will do little more predictive and the analytics on top of the earlier behavior, and you get much tailor-made data to you, so that your job becomes even simpler in terms of a decision maker. That can be mostly we can do, only human being can do that. Maybe in the future it may also change slightly, but that is where these technologies are really helping to handle this data explosion, whatever we are seeing around us. So I think that the one answer is, Harry, we need to use the tools, and we need to use what is needed only. Rest we can keep in the lake, use whenever needed. So for example, in organization, we keep data, including the emails, for 21 years. So these for legal purpose, for regulatory purposes, and many, many reasons. And we only touch when it is needed. We don't go and touch each and every day we cannot do that.
Thank you, Sreelal. Thank you, Vishnita.
So I think we any other questions from the audience? Jayashankar, you are doing some data science, right?
Yeah. So I'm Jayashankar. First of all, thanks for the informative session. And my doubt is regarding a career in data science. Actually, I had completed a small course on data science, but I'm working right now as a content creator. So it's actually a non-technical field. So how far we can, switch career to a data science field for a person like me who is working in a non-technical field. I'm also having non-technical background. I'm like you itself. I have also completed a graduation in physics. Actually, was graduation in physics. So that's my doubt. That's my question.
I think as simple, right? So when you say data sciences, it's a spectrum of job profiles. Certainly, there are a lot of requirements and a lot of opportunities for analysts to start with, right? So data analysts, statisticians, and business analysts, I think that is the one step that you can certainly think to take to get into this, the set of or the spectrum of positions or the spectrum of jobs within this data engineering, which is like I wouldn't call it as an easy step, which is something like a non-technical step to join the stream. Right? You don't need to be really a programmer to do analytics, right? So you need to be good in maths. You need to be good, have a good background in statistics. You should have some experience dealing with some simple data analytics, work, business analyst work, and slowly you can join the stream, and certainly you can. I think you can step into more of a product owner kind of a profile over the period, who is actually will deal with, interact with the business, understand the need of data, and deliver the data that they need, and the work will be done by engineers for you. So you can always think in that aspect.
Okay, sir. Thank you, sir.
Yeah.
There's another question, like how the hardware limitations affect the data science field. You want to take that up? I don't think there is any hardware limitation, because we have the cloud computing and we have abundance of computing available in the storage. And we
so certainly growth the same as our engineer as a software side, right? So hardware
we have power in terms of CPU.
Sadly, hardware hardware is also growing in terms of new innovations and technology, and we know how fast just takes an example of our mobile phone, right? So we used to have a very simple mobile phones, and now a mobile is almost doing everything that a computer is doing. So the hardware and the size is almost the same thing, right? So size has not grown, but the capability or the performance or power of computing has grown even in our mobile phone. Similarly, hardware, if you think of the cost also, right? So hardware cost has relatively come down. When you think about storage, hard disk, how much costly it was for a hard disk. Now it's like, terabytes of hard disk is now being available in a low cost. And also, in terms of big data storages, if you look at the big data clusters, we don't go with a very high-end, high-performing computers or storage nodes. We call it as commodity hardware, right? So commodity hardware means you don't need a very high-performing nodes within your cluster, because it is not just one or two nodes doing the actual data processing. It's like hundreds and thousands of computers together is doing your job, and you don't need every computer to be at a very high end, servers or high performing processors. You need, if you look at something like a master slave or master and the executor node kind of configuration, where you need high performing master nodes and relatively commodity hardwares for the data nodes, the worker nodes, whatever you call. So there's a lot of innovation. There's a lot of new technology innovation happening in the side of hardware as well to support this need. So the need is the one that creates every technology and every solution, right? So there is a need, and certainly there is solution. Yeah.
Okay. I think that we answered all the questions. The first one was about the resiliency of the data availability. That is also answered. So I think we have already closed the time. Shall we wrap up?
Yeah, I think Prasad added a couple of more points to the question to Jayashankar, which is really good. Like big data, there's a lot of trainings and a lot of available online. To learn Hadoop, which is highly, there's a lot of demand for Hadoop related positions. That will be a good starting point.
Yeah, I think as an add-on, right? If you come to know some opportunities for intern or anything, you could share with me. I will share it in the group.
Yeah.
Academic group. That will be just to add on
So
to
that will be quite helpful. As far as I had completed a small course on data science actually, but I could not do the internship because of the present work. So
yeah, we can look for part-time intern program. That way you can learn on the job. We will definitely help you, Jason. We'll try to get some opportunities.
Thank you.
And there is one more question: how is machine learning and data science are related? Sreelal, you want to address that?
They are closely related. So mostly it's like a two or three steps, right? So data engineering, if you took it, is more about I would call data engineering is part of the data sciences, where it is more dealing with extracting data from the systems and processing it and making it available for the machine learning algorithm to use it. So machine learning algorithms or machine learning is nothing but the consumer of a more refined and processed data. So it's like two phases of or two phases, you can call it like that. So first is your data science, where you build data data products, and machine learning is where you apply the machine learning algorithms and or build the machine learning algorithms and get the value out of it.
Yeah, to add to that, right? Machine learning needs very, very clean data to train the models. Right? Once you properly train the model based on the learning that the model has, just like how we learn, it will produce an output. So it's as simple as that.
Yeah.
So we need the data to be cleansed, properly categorized. We cannot. That is a proper input in computer science, right? Or any model or an algorithm, which will produce an output. So there is a lot of work involved in this journey. That is where the power of data and data science and analytics, where we have a lot of job opportunities also. It is not simple.
Yeah. Machine learning is mostly like a branch of artificial AI, artificial intelligence. That's where it is actually categorized.
Correct.
Yeah. So other one is more about data preparation, data sourcing, cleansing, and preparing it for analytical and reporting solutions to use it. And ML, machine learning, is one of them.
Correct. And thanks, Sumesh, for the question.
Yeah.
So I think we will wrap up. Chaitra, can we move to the? So first of all, I would like to thank Sreelal, who prepared a lot for this session, and it's also very open-ended problem that we gave to him to come up with a presentation on data, which we did not give a proper question. Like we always wanted to make it less technology oriented and give more insights to different angles. He did that job very well and came and presented to us. And we have this video already recorded, so which will be available to others as well in the future. So thanks, Sreelal. Thank you very much.
Vishnu, here internet interruption, so I am unable to continuously be in the meeting. In between that, due to connectivity, I have to go in and out playing. That is the reason. Okay, thank you.
No problem about that. So let's move on to the next part of the program, Chaitra.
വളരെയധികം നന്ദി സർ. ഹലോ.
Hello, Archana, please carry on.
താങ്ക് യു സാർ. ഉന്നതങ്ങളിലേക്ക് എത്താൻ ആഗ്രഹിക്കുന്ന ഒരുപാട് കുട്ടികൾക്ക് സാറിന്റെ ഈ ക്ലാസ് ഫലപ്രദമാകുമെന്ന് നിസ്സംശയം തന്നെ നമുക്ക് പറയാം. അപ്പോൾ ഒരുവിധം എല്ലാവരുടെ സംശയങ്ങൾക്കും മറുപടി ഉത്തരം ലഭിച്ചിട്ടുണ്ടെന്ന് പ്രതീക്ഷിക്കുന്നു. ഇന്നത്തെ പരിപാടി അവസാനത്തേക്ക് അടുക്കുകയാണ്. പരിപാടിക്ക് നന്ദി രേഖപ്പെടുത്തി സംസാരിക്കുന്നതിനായി മിസ് ആര്യ നന്ദകുമാറിനെ ക്ഷണിക്കുന്നു. മിസ് ആര്യ നന്ദകുമാർ. ഇന്ത്യയുടെ വിവിധ ഭാഗങ്ങളിലായി 175ഓളം വിദ്യാലയങ്ങൾ വിജയകരമായി നടത്തുന്ന മഹാഋഷി ശിക്ഷാ സംസ്ഥാന്റെ ജോയിന്റ് ഡയറക്ടർ, മഹാഋഷി വേൾഡ് പീസ് മൂവ്മെന്റ്, മഹാഋഷി നാഷണൽ യോഗ പ്രോഗ്രാം, മഹാഋഷി സ്കിൽ ഇൻസ്റ്റിറ്റ്യൂഷൻ തുടങ്ങിയവയുടെ വാർത്താവിനിമയ വിഭാഗം സെക്രട്ടറി, ഹ്യൂമൻ റൈറ്റ് കമ്മീഷൻ ഭോപ്പാൽ ചെയർപേഴ്സൺ, ചെയർപേഴ്സൺ ഓഫ് ഓൾ ലേഡീസ് ലീഗ് ഭോപ്പാൽ ചാപ്റ്റർ എന്നിങ്ങനെ സമൂഹത്തിലെ വിവിധ മേഖലകളിൽ കരുത്തുറ്റ സേവനങ്ങളിൽ നിരതയായ മിസ് ആര്യ നന്ദകുമാർ യോഗക്ഷേമം ഭോപ്പാൽ ചാപ്റ്റർ സെക്രട്ടറിയും മലയാള മിഷൻ അധ്യാപികയും കൂടിയാണ്. അഭിമാന പുരസ്സരം ആര്യ മാമിനെ പരിപാടിയിലേക്ക് സ്വാഗതം ചെയ്യുന്നു.
Thank you, Archana. Sadashiva Samarambha, Shankaracharya Madhyama, Asmad Acharya Paryanta, Vande Guru Parambara. A very good evening to one and all. Honorable Chairman Sree T.V. Madhavan Nambudiri, today's chief guest Sreelal PP, board members, ladies and gentlemen. The best and beautiful things in the world cannot be seen or even touched. They must be felt by heart. Thank you is one such prayer among them. It is a great honor and privilege to propose vote of thanks to all who have helped us in making this program such a resounding success. I take this opportunity to express our gratitude to our Honorable Chairman, Sree T.V. Madhavan Nambudiri, for sparing your valuable time to attend and preside this program. Secondly, on behalf of Sri Raghavapuram Sabha Yogam Academy, extend our sincere thanks to today's chief guest, Sreelal PP, for sparing his valuable time to attend and gracing today's session. Thank you very much for your very interesting and informative address. We all are inspired by your valuable words. Further, we are grateful to Sri Jyotish Sri Krishna for the wonderful welcome speech. My sincere gratitude towards all the members of the board and especially to the secretary, Sri Raghavapuram Sabha Yogam, Sri K.P. Hari Nambudiri, for his untiring efforts to uplift Sabha Yogam Academy. I would like to express our sincere thanks to prayer in charge of today's evening, Miss Megha Sharma, Sri Vishnu Nambudiri for introducing the chief guest, Miss Niranjana and Miss Archana for beautifully hosting the program, and Miss Chaitra for beautifully coordinating the program. This program would not have been possible without the valuable presence of our wonderful audience. So a big thank you to all of you for joining the program and staying connected till the end. I would also like to thank all the people who worked behind the scene to make this event happen, including the technical team. Wishing you all a happy Onam in advance. Thank you once again. Good night. Take care.